Hey everyone, so I'm going to talk about Scala and functional microservices. Yeah, I'll try over here. All right, that works. So hey everyone, I'm Jason Swartz, work at Twitch right now, and I've done a lot of work at eBay and Netflix on writing services and microservices, and want to share a little bit about how to make them functional, because we're Scala fans and we like functional programming. So I've been doing functional programming for a while, worked on a book and really got into it. I've been at Scala by the Bay several times and SF Scala for a while, and it's great to be back here again. Okay, so that's what we're doing today. The functional microservices. Start on, okay, I used to have like a what part of this, but I think everyone's heard of it, so I don't want to repeat it for everyone. Microservices, 2016 is calling and saying microservices, so that was big at the time. The why part's still really interesting. Core thing is a lot of people kind of make the move from monoliths. Monoliths are great, Ruby on Rails, there's Python, Flask, PHP. They're a great way to get your business up and going quickly. I can't think of a single place I've been which didn't have a monolith, which made it successful, which you then now have to fragment. At Twitch, they started with Rails, moved to Golang. They kind of moved everything over about 3 years ago. Last month, we finally removed the last bits of some Nginx things and shut down Rails finally. I mean, it's a long tail. It's a lot to remove, but there's a lot of good questions to ask when you make that move. I mean, monoliths are, it sounds bad, but they're not terrible. I mean, so let's say you have a monolith. You have it in, it could be in Play, it could be in PHP, Python. You're thinking, oh, there's so much code. This is a problem. I'm going to go ahead and fix this. Well, the monolith itself isn't that bad. I mean, all the code's in one place. That part's nice, right? You could use your IDE and you'll find all the code that exists. It's easier to talk to each other. You're not going to have issues with one part of the code talking to another. And, when you deploy it, boom, all of your code is deployed. So, hey, monoliths. All right. And that's the whole talk. That's pretty good. Thanks, everyone. That's keeping it short. Of course, the problem is it's a little bit hard to scale them, even if you have a whole bunch. I mean, it's a lot of stuff. You can't just say, I'm going to deploy one part of it. You pretty much deploy all your code at once. And that third part's the most interesting. It's the people. Pretty soon, once you start to scale up your engineering organization, you find it doesn't work out so well to have a lot of people in one code base. It gets a little bit tricky. Who's seen this before? All right, who knows what this is called?
Conway's.
Yeah, this is Conway's law. So it's pretty awesome. Your organization is going to produce something that kind of matches how you communicate. Classical thing is if you're an engineering company and let's say you sell a compiler as a product and you have 4 engineering teams, probably you're going to deliver a 4-pass compiler, seriously, because it's going to match your structure there. Hard part is if you start having if you have a monolith and you're a startup, your organization's a monolith. If you start having a lot of engineering teams and your team structure doesn't really match the software that you have, that's the huge issue. And that's why you usually want to break things up into microservices. So now people can own their own parts of the code. Okay, so let's talk about this a bit. Microservices. Oh yeah, people, forgot that part. Okay, so microservices I think makes sense, but you have to figure out if it makes sense for your group. Do people know how to deploy them? Can they think in terms of them? I mean, I would never start with microservices. I'd start out with monoliths. Build a massive play framework, build a big app, get some money, get a business going, get successful. Then when you start scaling, saying, okay, we should break up, because there's a lot of challenges doing that. You have to make sure you don't actually accidentally take down the business or something. So I want to talk about a sample application. So we all know Jira and other issue things, right? All right, so that's a basic model. Let's say we have a monolith that's called tasks and it does everything to do with task management and it writes to a database. I didn't come up with this, as I think the previous speaker said. We've been doing this for 25 years. Okay, that's pretty straightforward, I think. We all know about that. This kind of works though, with one team. When you start getting If you want to break it up a little bit and say, hey, we're going to do something like Jira, and we have one service that manages the issues, and you store it in one place, and you have one place that manages the users, put that in another place. Now it's like, oh, okay, that'll kind of work. That's like, that's good for, 2 teams. That works pretty well. And then as you start to work with it, you can figure out, oh, okay, we should design our services as we design our group. You can either start splitting apart your monolith into microservices to match your team. Of course, you can also reorganize your teams to match the software. Anyone heard of that? It's actually called the inverse Conway maneuver. And a lot of people do it, and then they're surprised to find there's a name for it. Yeah, you move the people around to match the software. Either way, I think it's really nice just to think about this, to say, how can we be effective and kind of own our own parts of the software? Anyways, if you're doing microservices, the name micro part's kind of obvious. Hello. Oh, and I'm hitting the wrong thing. That probably doesn't help you at all, trying to read this. It's nice. You can kind of split the data. You don't have to have one big place. Another common feature is, they're kind of isolated. The idea is if one thing goes down, maybe the other one should still be up. You don't take the whole service down just because there's one bad egg. They should be resilient, right? Also nice to have, same thing, you should have them pretty small, you should have private data. Hey, look, it's the same thing as the benefits. So you don't always get this. It's nice to have this. I think these are not, you don't always have this with microservices. I think this is what you should try to shoot for. If you can have this, if you can get there, if you can keep them small, if you make sure they're isolated, I think, what do people call it? Reactive? Similar thing, reactive, resilient. If you can make sure that they're really strong that way, I think then you're set. All right, so that's microservices. I'm just kidding, I'm going to keep talking about this. Now to really make this interesting, who's done work in service meshes? Is anyone using anyone using Istio or Envoy or? All right, well, it's a really nice way to say, okay, now that we're going to deploy these, how do they find each other? How do we talk to them? Do we have like a fixed load balancer? Do we know how they work as they scale? Do we have a good way to get access to each other? Findable, monitor, scalable, I think I have 1 or 2 others. Resilient, the R word comes back. And reactive. Who can tell me what a reactive microservice is? Oh, come on, we've been hitting with this buzzword. Oh, you, sir.
Yeah, depending on the load, you can create new ones. So basically, there are 2 asynchronous, different asynchronous, and you can pass without actually coupling.
Oh, that's pretty good. Yeah, we do have scalable and kind of, to indicate they should be able to, you should have a way to grow it. They should be resilient. They should be able to be by themselves isolated. They should be able to, you should be able to take one down and the other still work. And they should be generally reactive. They shouldn't necessarily block. They should be able to handle a lot of throughput. They should really be able to work, I guess a good way to say it is they should be able to react to any kind of traffic that you send to it. Anyways, this is the nice to have some microservices. Any questions so far? I'm not going to tell you how to do it. I just think it's nice to have. I mean, wow, this would be great. All right. There's also a lot of challenges if you then go to microservices. For one thing, instead of making local calls, you now have to have one thing talk to another. You have to figure out the lag, the throughput, the latency. You could have different data formats. You do have to find a service. You have to make sure it's up and keep track of that. Troubleshooting a monolith isn't actually so hard. If you then have 10 or 20 or 50 or like 100 microservices like we have at Twitch, it gets to be a little bit challenging to make sure you're on top of them all. And a little bit more. So I'm not saying microservices are bad. I'm saying they can be bad. There's a lot of trade-offs. Monoliths are kind of, I should have just said functional monoliths and just said that's my talk. No, there are a lot of people who run into issues with microservices and keep splitting them up. The more microservices you have, the more you have a distributed system. Really important to keep on top of that. All right, I will tell you a little bit about how to build it. So the how part, microservices in Scala, now we're getting into it. Good question. Well, Okay, you tend to want to get this wrapped up and put into production. Generally with Javas, traditionally you can package the whole thing as a war, for example, package it as a jar. You can bake in AMI, you can put in a machine image. Right now, I have the Docker images highlighted. That's kind of the default way to do this. Who's deploying apps in Docker format right now? All right, for people who aren't, what format do you use to get your software to production? It does work, yeah. I like Dockers myself. I think the nice thing is people who tend to work with Dockers, they can work with, you can have Golang services, you can have Java, you can have C#, you can really have so many options, and your infrastructure is very unrelated to actually how you develop them. I recommend Docker. It's been great with Mesos, Kubernetes, ECS, really taking off. On that note, a lot of different ways you can deploy this now. A lot of people have continuous development. Well, a lot of people have CI to start with. Jenkins, you can build it, you can click a button, deploy it to production. That's how we do it in my group. If you're really if you're really confident in your tests, you can have your CI just deploy the whole thing to production, and maybe send you a note, hey, by the way, I deployed that stuff to production. I hope that's okay. Continuous deployment is what it's called. Really nice to get to that point. VMs are still very popular. VMs, Amazon Machine Images, Spinnaker was a Netflix tool, spun out. It's a really popular way to do blue-green deployment, and it's actually very hooked in with Kubernetes now. Docker deployment, again, very popular. I'm using ECS on Amazon. I find that works out really well. A lot of people love Kubernetes. You have Kubernetes on Amazon now. Of course, you can get it on Google. Who's using something that's not on here? Yeah, it's kind of a big slide, kind of covers it. I kind of like ECS. I like to have things deployed super fast. We're able to find that we can get, with our service, about 150 instances deployed in about 2 minutes. It's really nice it's really amazing the strategies you have. Core thing is, when you're deploying microservices, if given that you might have 10 or 20 or 50, getting the deployment right is really important. Getting your monolith uploaded isn't a big deal. You get it done, and that's all there is to do for their services. You generally really want to make sure you don't have downtime, you don't create issues. All right, so this is just kind of a breezy overview. Hey, question, should I deploy to the cloud? Yeah, totally. Oracle, because I'm here at Oracle, or Amazon, or Google. At this point, it's getting harder and harder to justify not going to the cloud. I'm not even going to open this up to questions. I'm just going to be on the side of yes. I'll be standing here later. Please come up and change my mind. Next thing. What's that?
Oracle's the best one.
Okay. Other people say, ooh, should I throw tests at it? Yeah, I think that's awesome. If you combine we're going to test the heck out of my microservice with we're going to have it automatically deployed at production because we're pretty darn confident in it, I think that's a big win. I'm all about automating the drudgery. The testing part is super important. Generally, you want to find out the issues before your customers do. If your customers start telling you there's problems, it's a little bit too late. But you can also just come up and try to change my mind on that too. I'm not going to go too much into this. It's just that with microservices, it starts to get a little complicated. It is a distributed system. Some things to think about is how they're going to talk to each other. How do they find each other? If you deploy new services, how do they get found? Are you using DNS names? Do you have a smart way to keep on top of it? If you have 50 microservices and one of them goes down, how can you tell? How can you keep on top of it? It's a challenging area. It's why I was kidding around and saying, hey, monoliths are actually pretty awesome. I changed my mind. It starts to get a little bit challenging with microservices. It is important, I think, to get these things right. In fact, I bet they have information on this at Scale by the Bay, Alexi. Well, I'm going to find out. I think actually the one I should have put on here, Envoy, they do have some great service meshes now written in Scala. I think Envoy is one that came No, it's not Envoy. No, not Envoy. Linkerd. Linkerd came out of Twitter. It's really amazing that they have Scala-based service mesh. I think it's worthwhile to keep track of these things. It's important to get this right because services aren't necessarily live distributed systems. All right, so let's talk about the development part. That part's fun. I like the development of them. Little bit about the framework. Who's using a Scala framework not on here? Yeah. Oh, what are you using?
A little bit of HTTP for us.
Oh, very nice.
A little bit.
Yes, and back. Yeah, I should probably put that on here. Play's continuing to be really, really popular. I've been happy with it, although it does include so many things such as web templating. You tend to build monoliths with it pretty quickly. Lagom is, now has Scala, I think, for about the last year and a half. I think it has really good support for event sourcing. It's a very different model, requires a little bit to get into. Akka-Http, wait, did that become HTTP for us, or is that different? No, okay, that's. And you know, I hate to say it here at SF Scala, Spring Boot's going to be more and more popular. There are a lot of people who still think of, here's Spring, and they think XML, and they think, I've seen too many open brackets. But it's nice. A lot of Spring developers are very happy with it. It's actually a very common way people started with Java and switched to Scala on the way. All right, enough about frameworks. I think this part gets really interesting. I'm not really, I know I have Postgres there in bold. I'm not really going to talk this up, except that don't just choose one data store. I think it's important to find the right one. I like Postgres a lot for reasons I'm going to get into shortly, and Maria as well. I think it can be important to use the right data store that's available or more than one. Let me show you what I mean after I try to click my thing here. All right. I'm going to use CRUD here. I think people know what that is. All right. I want to get into this. I think it's important to talk about CRUD and how you store things. I'm going to get a little bit of a deep dive into this. So I never thought I'd do this, but I did an animation on CRUD. That's right, CRUD. Create, read, update, delete. All right, obviously you all know what this is. This means this is a basic for REST APIs. You want to create an item, you want to read an item, update and delete. It seems obvious, right? This is pretty simple. Yeah, all right, that's good. I mean, I don't want to be too challenging here. So we do Scala, we do immutable data, right? We're used to saying, okay, if I have something, it's not going to change. If I have a list, if I have a data structure, I can share it between different threads, for example. I can grab it from the future and it doesn't change. And I have all these wonderful methods in the collections library which take advantage of first-class functions so I can work safely with immutable data. But who's using immutable tables? You are. Oh, exactly, yeah, kind of add on to it. Yes, great. Did you know that you can actually do immutable data in MariaDB and Postgres? You can actually think of them as immutable data stores. And I think, yes? Whoa, hey, it's not part of the demo. That's not mine either. That message is more for my daughter to say, hey, this is daddy's. All right, thanks for the message. But yeah, immutable data, we all know immutable collections, but what the heck are immutable tables? Okay, so let's say I have a task. I'm implementing Jira. I have a tasks table. I have, hey, is this done? I have a title, I have an assignee. This schema makes sense, right? It's a relational table. We're all kind of familiar with that. Let's say I have a REST API. I want to update my issues a little bit. I have a get to get all issues, to get one issue by ID. I can create an issue and I can update an issue. Does this make sense? All right, we're all pretty familiar with that. Question is, if people call this, what actually happens in the database? And that's the functional part I want to get into here. So at the top I have the actual call that's being made, and I have the table that's being changed below. So think about this as an exercise. Let's say I do a post. What do I get? What happens in the database? Well, I mean, if you do a post, that's supposed to create something, right? So it creates this row in the database. Okay, great crowd. No, next slide. All right, so I posted. What does a put do?
Update.
Yeah, so I just updated it. All right, look at that. Okay, this kind of looks well. And let's say the next step I do is a put again, and I kind of change done to true. Is done true? Yeah, so this makes sense, right? All right, yeah, like it. Anything wrong?
You lost the assignee.
Yeah, how?
Your second put.
Well, yeah, but hard part is, I mean, if you look at the table down below, it doesn't really look like it matches the events that came in, does it? I mean, you kind of miss something. You're like, well, wait a sec. We had an assignee. I'm not sure why that's null. I mean, if you just say, if you don't even know what the items that came in are, and you're just looking at this table and you're trying to debug it, how will you construct the list of events in your mind? It's a little bit challenging, isn't it? You're like, well, oh, gee, I forgot the lessons of shared global state, and our database table is a shared global state, and I don't actually know how we got there. So it's a little bit troubling. Problem is, if your table rows are mutable, you're not going to have any history. Mutable table rows suffer from the same issue as like a Java array list. They have the same issues as mutable collections. If they're mutable, you lose track of how you got there. If your table rows never change, though, you have history. You have everything you need. So I'm going to propose, consider that you can change things in the database, but each row should be immutable. Think of your table rows as like a mutable linked list. You can add stuff to the end. But what happens if you never change a table row? You'll have kind of a history, you'll have a change history of everything that happens, which I think works out really well. You're kind of locking down what happens at every point. Let's see this again. Okay, I post, I create a table entry, killer. I put, oh, I didn't change anything. I just inserted a new row. Well, that's kind of nice. Let's say if I put again. Haha, there we are. So the ID isn't really unique. The ID is something that says this is the entity ID, not really the row ID. And it looks like I have timestamps so I can tell what happened here. So what happened at 19 after the hour? Can someone tell me? Well, someone must have done something, and someone must have called put and cleared that. It wasn't me, but at least I have a record now. I know that at that time, someone cleared that. Something happened, came in maybe through a different access log, came in from somewhere, but we have a pretty clear record now. If we then added something like request IDs or X-ray IDs or something, or even a user ID, we'd have a pretty good track record of figuring out exactly what happened in this. So this is a mutable table. You can say, hey, get one, and you can have a nice query that says, I'll give you the latest entry which has the entity ID that you want. So to the caller, they don't have to know that your table is immutable. But you can actually do better. There are ways to build a append-only table. This sounds like a joke, doesn't it? I mean, but it's not. Good way to start, let's say you have Postgres or MariaDB, you want to make your tables immutable. First thing you do is don't let your application do updates or deletes. Take that away. Next, you can actually do that. Pretty simple. Next thing to do is have good columns to support an append-only table. Here's a good example. Here we have ID, like the row ID, which is actually the row ID, but now we have issue ID, which is an entity ID. So the row ID is unique, but issue ID, I can have multiple copies. And I can say, oh, not just created, but I have a creator ID, so I can see the user who did this. So if we have someone who calls this and clears out the assignee, I now have a whole history for every change that happened here, and I can see who did it. You don't have to do this. I'm just saying this is a really nice way to have an append-only table. You can use this. You can keep using your Postgres or Maria database, and it'll all work really well. Okay, now let's switch it up. Let's say you don't really need Postgres. Let's say you don't really need Maria, you want to change it out. We actually did just talk about event sourcing in the previous talk. Does anyone, who's curious about what event sourcing is? You are, sir. All right, I'm going to dive in then. So this is the immutable idea. I think the things at the top are HTTP actions, right? They're API calls. The stuff at the bottom is the state that happens as a result of your HTTP call. I like to think the stuff at the top is an event. You know, you're saying create this, and then update this, and then update this again. The stuff at the bottom is state. The funny thing is, I could probably reproduce the bottom part just from the top part. If I have a list of all the actions that happen, I may not even need the state at the bottom. So the event sourcing idea is, let's just track the events and you could build the state from it. The state is dependent. I mean, look, I create an issue and the state is issue created and I assign it to someone and it's just an update and I complete it and it's marked as complete. But, you know, the state's nice, but I'm not sure I really need it. State's virtual. I can build it at any point. Basically, I have a tape. I can replay the tape from scratch and build out this item. So the event sourcing says, let's store the events. Let's actually store and persist them somewhere. And then the state can be built at any time. Does event sourcing make sense now? All right. And that's, obviously, you probably don't have enough to actually build something like this now. It's just the basic concept. But that is kind of the concept. The event is the source, not the state. All right. I just said that. Here's an example. One challenge, though, is what's the format of an event? What are you storing in the event? A lot of times with at least dynamic languages, a lot of people say, well, let's have an event and just store it in JSON, store it in YAML, and put that in the database. Or let's convert an object to some kind of textual form and convert it back. Let's use a relational table just to store that there was an event and have something else to say, okay, we're going to unmarshal this back into something. But it's nice. Okay, I'll kind of move on. I think we kind of covered that part. Yes, real event, virtual state. Pretty straightforward, right? Yes, sir.
You know, eventually events build up, and you have some data sources that are just continuous. And you can't rematerialize it in the stream of events forever because the performance penalty is too high. So what's the pattern for those systems to compress that out?
Common pattern is to say we'll only store those events for a certain amount of time. There are some places where you, like if you have an order at Amazon, it's probably only going to be live for a certain amount of time. And then you could say we won't accept any more updates. You can materialize that to a separate table and not worry about that. I think event sourcing is more useful when you have events that are, when you have more ephemeral data. For longer lived item, you're right, it can be a pain because then you don't want to have to say, oh, let's figure out the state by rebuilding it from scratch. Faster systems will often materialize this to temporary tables to say, here's the state as we know it, but say, okay, we got new events, so we have to mark this table as false. It's probably a trade-off that depends on what kind of system you're building. And if you're building something where the events will only come in at a certain amount of time grouped together, or if you're going to have them over a larger time, you probably want to start from some level. In video compression, you usually have keyframes, which say, here's the full frame, and then after that you have a certain number of diffs based on it. But at some point you say eventually it starts getting out of track and you just want a keyframe every few items.
So for old people, that was like the old IBM idea of checkpoint restart, basically.
What's it called?
Checkpoint restart.
Is that the same as turning it off and on?
No, you would do event sourcing, and then you'd say, yeah, I've been doing this for an hour. I better save my state right here, and if I die after this, I'll go back to the state as an event source.
Ah, crap! I thought this was new. I figured. Next, you're going to tell me functional programming was not invented with Scala. Ah. I should have written more down in college. But thank you for clarifying. Thank you for having me clarify. All right, the why part's kind of interesting. I think it really depends. In some places we found immutable tables really useful if we already have a regular system set up and we don't want to change everything. Last place I was at, we used Append-Only tables for anything to do with finance. If people paid money, if they had subscriptions, we needed every version of it. If you have people doing something you don't really care about, you can probably update the tables. Nice thing is, immutable Append-Only tables can live side by side with other information. If you really want to make sure that you want to write stuff fast, for example, Cassandra is often used with event sourcing because you're appending stuff super quickly. If you really are able to build your items so that the commands and writing in the events in is very different from where you read it out, event sourcing could work. This is just a short list of 6. I'm not saying this is the easy way to organize it. It's pretty useful though. I can see how Oracle Cloud would want to be, have performance be a major issue and design for this up front. Any questions about event sourcing? Yes, sir.
I have an idea that might become a question as a talk. If you already have a database that you're inserting and mutating to, and you have the bin log for that database, that bin log is sort of an event source. So have you used that to an advantage in transitioning to a read-only table strategy, or using that as a source for data in your event source?
I haven't before. I think it's highly dependent on the exact version of, I assume, MySQL?
In whatever has a bin log, right? So if
Yeah.
you're using a bin, or using MySQL bin log, but not for event sourcing, just for database recovery based on
I've done that too. I've used it for like basic replication before. I don't know. I don't really trust that. I don't trust it's going to have everything I need. I know it has everything necessary for the database. It's starting to get a bit low level. I don't think the bin log's really created for that.
Okay.
Is that fair? I mean, I'd rather have tools. For example, if you have like a subscription record, say, hey, here's my subscription to a gym, and you have updates, you may want to say to the user, what's my current status? But if you're calling customer support, you may want them to see your whole history. It's nice to be able to say, show me the latest one versus show me the entire history of everything that's happened.
Yeah, but if you're writing some sort of pricing consumer that's going to update that account information for whoever's viewing the account, the updates to the bin log could feed that other database that has the individual rows, whereas the end user is still consuming the primary.
Yeah, that's true. I mean, usually the framework's set up so that you kind of separate the command and the query, and the commands you make sure are really put in order. I mean, usually these things are designed that way. I don't know. It could work to use the bin log, but I like the idea of event sourcing. The events are immutable. That part's nice, right? I mean, some systems you pull in events and say we don't allow that event, or this is not in the right order, but pretty much they don't change. I mean, it's pretty awesome. You can play it back. You're saying, hey, I want to control the version of how this stuff changes. This sounds like a certain 3-letter version control system, right? No! Oh, man. Okay, well, we like all having control over this stuff. We all use Git. We're very familiar with it. It's nice to be able to say, hey, okay, I'll be specific. Yeah, no, sorry, but close answer. Yeah, there's 3 letters. That part was good. But it's nice to be able to say, I want some control and transparency into exactly what happens with my data. I think event sourcing is a nice way to get there. Yeah, I probably should update that. Even as of 2018, it's a little bit non-standard. It's a little bit hard to understand. And you really have to design for it. I found, again, this is super useful for extremely high accuracy systems like financial trading. I found it very useful for extremely high performance. I'm not sure it's quite caught on as much. I think it's just another good tool to know about. I think that's the part of Microservice development I was really going to get into. That's the whole thing. I'm just kidding. All right, so that's everything. That's what I want to talk about with functional microservices. So this is great. Thanks for having me here today. I'm Jason Swartz. This has been kind of fun. And thanks.
We have a question, so please repeat the question.
patching your database?
Have you ever tried patching my database? What do you mean?
As in like a patch rather than a put, or updating just changed columns in your immutable table?
Oh, yeah. Yeah, put is a little bit weird. Put is where you're supposed to put, are you talking about the HTTP patch? Is that right?
And then just updating changed columns in your database.
Yeah. So supposedly patch is when you want to say, I want to update just one field. Put says, here's the entire new version of the field, for example. So I actually usually use patch with things like examples I gave, where you just update the assignee or just update one thing. Put, you're supposed to give the whole record. I probably use put here because it's easier to type than patch. Yeah, traditionally it depends if put is supposed to be for entire items. But I like the idea of just updating one item at a time. It gives you a nice history, a nice overview of exactly what changed. Did I answer your question?
A little bit. I guess what I'm really digging for is like, do you have a nice pattern for taking a bunch of rows where most of the columns are null and squishing them into one valid row that you can return back?
Yeah, I didn't include it here, but I use window functions in Postgres. PostgreSQL supports SQL 2003, which has window functions, which you can say, select every item in there, but group by this entity ID, and then just order them by the most recent first, and then just give me the first one from each row. MariaDB has SQL 2003 window functions. MySQL 9, or I think MySQL 10 does not have them yet. It's a nice way to say, hey, I want to be able to query things, but only take the most recent entry for a given entity. But that way, people who call, your REST APIs or GraphQL APIs don't really have to know how you have it implemented. They'll still get the right thing. These queries are pretty fast. They do hit the indices, but it means you have the whole history and you have control over exactly what people can see. Any other questions? Yes?
Yeah, this is in terms of the event sourcing. So when we do event sourcing in distributed environment, is there a way we can ensure transactional consistency? Because if we have distributed system, distributed application layer, events can come to that application layer at a different time, but the database layer can go in a different one.
That's a super question. Now, eventual consistency, do you mean that they're actually put into different storage systems?
We have this one storage. So storage will make it in different order. So my application layer.
Okay, so I think you're saying what the problem is, you might have events coming into different parts of the system that eventually make it into the same storage, but how do you trust what order they came in?
We have a pattern.
Usually I trust the database itself. I've used MySQL and Postgres to have multiple events coming in and only take the first one. Like typically anything I do with SNS or other eventing queues, I'll typically honor the first one by having a uniqueness constraint that says here's a uniqueness constraint for the type of event coming in and the ID and a basic version of the originating timestamp, and use the originating timestamp to say we'll only support the first entry here. That's why I've seen. That's a good question. Does anyone have ideas of how to, I guess, disintermediate or figure out the correct event to use when there's conflicts? Because there will be conflicts. It is one of the issues you have with distributed systems. I guess probably if it's the same, is it the same event or is it conflicting events?
We have a problem with conflicts.
I guess, can you do locking within a mutable table?
Sorry, can you repeat your question?
Can you do locking on an immutable table? So say you
Oh.
have your assignee update, so you assign to one person, and at the same time you get an event to assign to another person, who does it end up getting assigned to? And you provide guarantees around one of those. I'm not saying that both of those are. I mean, in the assignee case, it's kind of obvious, but
Yeah.
in cases where that is acceptable.
It's a great question. I'm not familiar with patterns of how to do that for modern databases. When I was at eBay, we worked on end of auction code, and there you really have to make sure you honor the correctly. we actually had business events in Oracle tables where when you inserted, part of the query for inserting something was running a trigger that would go through and make sure there weren't anything competing items at the exact same time in the exact same table. So we would shard based on the user ID, based on the category of the item, and then if you insert, you don't just do an insert, you do an insert and business processing event at the same time. Probably doing it at the database level is one way to make sure you don't have competing entries in there at the same time. I hate to say it's locking, but that is, and stored procedures and triggers are a little bit less common now, but for something like a financial system or something where finances or auctions are at stake, I'd say try to shard and get it down so that you can actually have logic at the database level for that. Great question. All right, thanks everyone.